Hello, dear all. I hope everyone is doing well and enjoy the lessons in our channel. Let's start. Today is the time for starting to learn about HCF and LCM. HCF and LCM. As you remember from our last lesson, we talked about factors, multiples, and we talked about common factors and multiples. Now I want to start from common factors and multiples again. I will take the numbers 12, 18, and I want to write the factors of 12 that are 1, 12, 2, 6, 3, 4. And the factors of 18, 1, 18, 2, 9, 3, and 6. Okay, now I will circle the common factors of 12 and 18. What does mean common factors? The factor that I see in this set and in this set. They are 1, 2, 3, and 6. So 1, 2, 3, 6. They are common factors. The smallest one is 1. The largest one is 6. We can easily understand that the smallest common factor for all numbers is always 1, as all the numbers are divisible by 1. But the largest common factor, we cannot easily say. We have to find out. So 6 is the highest common factor. H, C, F. And sometimes instead of highest, we can use greatest. That will be GCF. Okay, now it is time to find common multiples of 12 and 18. I will start with the writing multiples of 12. It's 12, 24, 36. Each time I add 12 to 84 and so on. We cannot end this set. We cannot end the multiple set. Let us start to write multiples of 18. They are 18, 36, 54, 72, 90, 108, and so on. Now I want to circle the common multiples of 12 and 18. And here I see two of them. They are 36 and 72 are common multiples of 12 and 18. If we continue this set, of course, we will get infinitely many common multiples of these two numbers. So it is just impossible to find the greatest common multiple. But it's possible to find the least common multiple. So the smallest, the least common multiple. LCM. Okay, so LCM of 12 and 18 is 36. Okay, now let us look at other methods how to find HCF and LCM of a number. Let us take two numbers like 54 and 36. Okay, let us find their HCF and LCM. I will not use a way to find the set of factors and multiples. I will use a way factorizing by prime factors. We call it prime factorization. Okay, what does it mean, prime factorization? In some terms, we can use factor tree. Let us see what this means, factor tree. Okay, we take 54, we write 54 as 3 and 18. 3 is a prime number that divides by 1 in itself. So we circle this. 18 is not a prime number, it's composite number. Let me write here, prime and composite. Okay. 18 is composite number, so we can write 18 like 2 and 9. 2 is the prime number, it divides by 1 and 2 only, but 9 is composite number, it divides by 3 and 3. 3 is a prime number, and here it's a prime number. So 54 is 3 times 2 times 3 times 3, or we can write it as 2 times 3 cubed. Okay, this is prime factorization of 54, or we wrote 54 as the product of its prime factors. Okay, now let us factorize 36 by its prime factors. Okay, I will write it here. 36 is 4 and 9. Both of them are composite numbers, so I will write it as 2, 2 that are prime, so I circle, and 9 is 3, 3, so I circled it. Now 36 is 2 times 2 times 3 times 3, or we can write it as 2 squared times 3 squared. Okay, so this is the product of prime numbers, the product of prime factors of 36. Okay. Now we have two circles. They are called Venn diagrams. The first circle for 36 and the second circle for 54. Now I'm going to write the factors of 36 and the factors of 54 in their circles. Of course, you know that the part in the middle, that the overlap with each other, it is for common part. Okay, what do I see in 36? In 36 there are 2, 2, 3, 3. And in 54 I see 2, 3, 3, 3. Okay, I see that these 3's are common. These 3's are common. And these 2's are common. So I can write in the middle 2, 3, and 3. And from here I see that 2 is alone here. It goes to 36 only. And here I see that 3 is alone and it goes to 54 only. Okay, let us check our answers one more time. Okay, in 36 circle we have 2, 2, 3, and 3, that makes 36. And in 54 circle we have 2, 3, 3, and 3, that the product is 54. Okay, so the middle part, the common part, is HCF part. The product of this area is HCF. So HCF of 36 and 54 equals 2 times 3 times 3. That makes 18. So the common factor, the highest common factor of 36 and 54 is 18. It means, guys, that 36 and 54 together, they divide by 18 maximum. There is no a number more than 18 that 36 and 54 both can be divided. Okay, now let us investigate the LCM one. HCF, we have already found that it is 18. The middle part, the common part, belongs to HCF. If we multiply the number that is in common area, the answer is HCF. But what about LCM? LCM is the product of all numbers here. Actually, this is the union of two thirds. That 2 times 2 times 3 times 3 times 3. That makes 4 and 27, 28, and 108. So LCM of 36 and 54 is 108. It means the smallest number, the minimum number, is 108 that divides by both 36 and 54. It means there is no a number smaller than 108 that can be divided by both 36 and 54. Okay, now let us look at another method how to find LCM and HCF of two numbers. Again, I'm going to use prime factorization. 36, I'm going to divide by only prime factors. It's divisible by 2. I can start with 3 as well. 18. Again, I can divide it by 2. This is 9. Divide by 3. The answer is 3. It's again divisible by 3. And the answer is 1. When I get 1, I have to stop because there is no meaning to continue and divide it by 1. And now it's time for 54. I divide it by 2. I can start with 3 as well. 27. I know that 27 is odd number and it's not divisible by 2, so I will divide it by 3 because it divides by 3. 9 divided by 3, 3 divided by 3, 1. Okay, again I get 1 and I stop. So now I'm going to circle the numbers, the factors that are same. Okay, they are same. For these two, we don't have any pair of 2 here. But for these 3, we have. They are common. And for these 3, we also have. They are common. So HCF of these two numbers are 2 times 3 times 3. That makes 18. But what is LCM? For LCM, we have a way that we can multiply HCF by non-common factors. Like 18, we can multiply by what factors are non-common here? They are 2 and 3. So 18 I will multiply by 2 and by 3, and answer is 108. Another way to find LCM from this method is one of the numbers, 36, I multiply by non-common factor of another number, that is 3, it is 108. Or 54, I multiply by a number by non-common factor of another number, this is 2, and the answer is again 108. So HCF of 54 and 36 is 18, and LCM of them is 108. Okay, let us investigate some cases where it can be tricky to find HCF and LCM. We talked about prime factors, prime numbers. Just very quickly go through them. Prime number 2, 3, 5, 7, 11, and so on. These numbers are prime numbers. It means these numbers are divisible by 1 and themselves only. The 2 has 2 factors, 1 and 2. 3 has 2 factors, 1 and 3. 5 has 2 factors, 1 and 5, and the same with others. So if a number has got 2 factors only, the number is called prime number. But composite numbers like 4 that has 1, 2, and 4, 3 factors, 9 that has 1, 3, 9. And for example, for 20, it has 1, 2, 4, 5, and 10. So if a number has got at least 3 factors of in a number, if a number has got more than 2 factors, the number is composite. In this case, what about number 1? Number 1 is neither prime, no composite number, because 1 divides by only 1. It has 1 factor, so it's not definition of prime and it's not definition of composite. And another interesting moment is about 2. As you see and investigate, 2 is the unique, it's the only even prime number. All the prime numbers are odd except 2. Okay, after looking at prime and composite numbers, let us look at some pairs of numbers like 4 in 27. Okay, let us find HCF and LCM of 4 and 27. If I divide 4 by its prime factors, I will get 2 that are prime numbers. So 4 is 2 times 2. And for 27, this is 3 prime, 9, and it's prime. So 27, I will write as 3 times 3 times 3. Okay. Oh, it's 2 times 2, and it's 3 times 3 times 3. There is no any common factor. What should I write? I have to write that there is no HCF of 4 and 27. Is it correct? No, of course. We know that 1 is the common factor for all numbers. So when we see, guys, no common factor in prime factorization, we write that HCF of such numbers is 1. And this pair of numbers called mutually prime. Look, separately they are not prime. 4 is composite number, 27 composite number, but they are mutually prime because they don't have common factor except 1. It's very important to say except 1 because mathematically if you say that 4 and 27 don't have common factor, it's wrong sentence. It's not correct. So you have to say that 4 and 27 don't have common factor except 1. So their HCF is 1. But what about their LCM? Okay, as we talked before, how to find LCM of two numbers, we say that their HCF, we need to multiply by non-common factors. Okay, when we follow this rule, the HCF of 4 and 27 is 1, and their non-common factors, actually all the factors here are non-common, so we have to write 2 times 2 times 3 times 3 times 3. As we see that it is 4 times 27. So we can say that if two numbers are mutually prime, it means if they don't have any common factor except 1, their LCM is their product. Okay, now let us look at another example. We have a number that 12 and 36. We have two numbers, 12 and 36. Okay, let us divide 12 by its prime factors. We get 1 and stopped. Okay, 18, 9, 3 by 3, 1. We stopped. Okay, now let us circle the common factors. 2 and 2, 2 and 2, 3 and 3. Okay, what is HCF? It is the product of common factors. So 2 times 2 times 3, 12. And what's LCM? LCM is the product of HCF by non-common factors. 3 is non-common here, 36. Oh, what did we get? We get that HCF of 12 and 36 is 12 itself, but LCM of 12 and 36 is 36 itself. So from here we can get a rule. If we have two numbers, when one of the numbers is a multiple of another, or one of the numbers is a factor of another, like in our example, 36 divides by 12. 36 is a multiple of 12, and 12 is a factor of 36. So in this case, the factor one is HCF, the multiple one is 36. So easy. Okay, and then the last I want to say that there is a formula where A times B is the product of HCF AB and LCM AB. Let us investigate this formula. Okay, we have two numbers that are 9 and 12. Okay, the 9 is 3, 3. The 12 is 3, 4, 2, and 2. So 9 equals 3 times 3. 12 equals 2 times 2 times 3. 3 and 3, they are common factors. So HCF of 9 and 12 is 3, but their LCM, common factor times 3 times 2 times 2 by non-common factors. So 3 times 3 times 2 times 2, it will be 9 and 4, 36. So HCF, if we have A and B, if we have 9 and 12, their HCF is 3 and their LCM is 36. Let us see. 9 times 12 in 3 times 36. We see that 9 times 12 is 108. 3 times 36 is 108. Okay, so there is a formula like this is our formula. A times B is the same with the product of their HCF and LCM. So today we'll learn, guys, what is HCF, what is LCM. We'll learn about prime numbers, we'll learn about composite numbers, we'll learn about prime factorization, and we'll learn about mutually prime numbers. Okay, thank you for watching, thank you for subscribing, thank you for sharing my channel among your friends and dears. I'm so happy to have all of you here. I will be grateful if you are active and if you ask your questions, if you text me, and if you enjoy here. Thank you.